Okay, let's continue in 2.6 with the algebra of functions. Now we'll get into adding, subtracting, multiplying, and dividing our functions. And I've given you a box here that you can find listed in your textbook, but it describes some of the notation that you'll see when we do these different operations. So when we're asked to find the sum of two functions, they'll ask us to do this. That just means add the two functions together. Or it could be written this way. That's just mathematical notation for take two functions and add them. This doesn't mean f plus g times x. This is our old function notation, f of x plus g of x. So if we see this notation, they're just asking us to subtract. We'll see it either way, and that just means f of x minus g of x. Subtract the two functions. Multiplication is the same. It doesn't mean times x, it means f of x times g of x. And f divided by g means to divide the two functions out. One thing we have to always remember when we have an equation with a fraction, or if we formulate an equation with a fraction, is we can't ever have division by zero, so we've always got to look at that denominator to see, to make sure we don't get division by zero. Then another important thing when we're working with combining these functions is the domain. The domain of the result has to be true to the domain of each one individually. The way we're going to find the domain of the result is to find the domain of f by itself, the domain of g by itself, and then find the intersection of those two domains. That will always be the domain of your result. So let's talk a little bit about domains. Okay, I have a function x minus 5 and a function x squared minus 1. From our previous work on finding domain of a function, f of x will not have any restriction. It'll be negative infinity to infinity because there's no radical, there's no root, and there's no fraction. What about the domain of g? No root, no fraction, no worries. It's all real numbers. Well, this one's pretty trivial. If I take the domain of f and find the intersection of the domain of g, since they're both the same, then it's just going to be negative infinity to infinity, which means every one of these operations I'm going to perform is going to have the exact same domain, negative infinity to positive infinity. But we have to do that first. So the operations, all the operations below will have the resulting domain to be negative infinity to positive infinity. It takes this domain, which is the intersection of the two individual domains. Now we're going to have to come back. I've got some stars here, so that tells me something's going on. We have to come back and investigate that. But for now, let's just mark it as all real numbers. Now let's do the operations. The operations are relatively simple. F plus g at x says, okay, take the two functions and let's go ahead and use the two functions we have up here. Here's my f, here's my g. Take those two functions and add them. So this just means f of x plus g of x. Well, it's simple enough. Just take x minus 5 and add it to x squared minus 1. It's simple. You just set them up in an addition format, working with the two functions given to us above. Now, if you can do any algebra and cleaning this up, I would prefer you to do that. So let's combine some terms and put this in the proper form. So x squared plus x minus 6. Always write it in descending powers. Just combine the negative 5 and the negative 1. Putting the x in the middle. Well, f minus g of x isn't going to be a whole lot different. It's just f of x minus g of x, which means let's set this thing up, take the f function, which is x minus 5, and subtract from it the g function, which in this case is x squared minus 1. But if I write the problem this way, I'm going to have an error because whenever I'm subtracting, I have to remember to distribute that negative sign. So my suggestion is to throw in some parentheses So you won't forget to distribute this negative. So the subtraction sets up just as easily as the addition. We just have to remember to distribute the negative. So let's distribute it and then do some more combining terms, cleaning this up algebraically. So we got the negative distributed. Let's combine terms. The x squared, nothing combines. The x, nothing combines. But plus 5 minus 1 is a negative 4. Next notation. F times g of x. When you see this notation, then you're just thinking it's f of x times the function g of x. So we'll set them up in a multiplication format. So f is x minus 5. G is x squared minus 1. We're just going to use our FOIL method to multiply that out. So working on the FOIL method, x times x squared, so I'll get an x cubed minus x minus 5x squared plus 5. And putting that in descending powers, we'll have x cubed minus 5x squared minus x plus 5. And check my work because I'm doing these fast. I could have some careless mistakes on here, so just overlook those if they do come up. And that's it. And we've got the domain right down there listed for us. Finally, last one. This notation tells me to set up an f of x divided by g of x. F is x minus 5, goes on the top. G is x squared minus 1, goes on the bottom. I can't reduce it, I can't factor it, I can't cancel anything, so that's the result of f divided by g. But here is where the asterisk comes in, because I have formulated a problem that involves a fraction, and I know when I'm dealing with fractions I can't have division by 0. When I formulate one of these, I have to come down here and change my domain to make sure I exclude the values by which the denominator could be 0. So let's look at the denominator of x squared minus 1. That is a quadratic that factors into x plus 1, x minus 1. Now again, this is our answer. I'm just working to find my domain restriction. Well, if I factor it, I get that, and if I set each of my factors to 0, I'm going to have to throw out negative 1, and I'm going to have to throw out positive 1 for my domain because of that denominator. So I have to come down here and state it some way, like all real numbers, x can't be positive negative 1, or I can state it in interval notation as negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Either notation, we need to be familiar with both. And remember, when we do end up with more than one interval, we have to put the U, the union, in between them. Last thing on this page is let's do a little bit with domains when they're not just all real numbers. So let's look at f of x and let's find its domain. Notice that f is a radical and it's an even radical, an even root, which means there's going to be a restriction because I can't take the square root of a negative number. So remember what we said earlier, set the radicand greater than or equal to 0 and solve it. We get x greater than or equal to 3. That's the domain of f. Let's look at g. It's another radical. We take the radicand, set it greater than or equal to 0 and solve it, and I get x greater than or equal to negative 1. That's the domain of g. So I've got the domain of f, which is here. I've got the domain of g, which is here. Now, if I want to perform an operation such as f plus g at x, I have to state the domain of the result. If we go back to our little box that I had copied from the book, it says the result is going to be where the domain of f intersects the domain of g. So let's look at those two domains. I've got -1 to infinity, and I've got 3 to infinity. So these, if I looked at a number line, would be shaded in that direction. Greater than 3 and greater than -1. Hello? Hey. Everything okay? Alright. I'm finishing up a lecture here and then I'm coming on home. Okay, I'm videotaping on my laptop. Okay. I'll see you in a little bit. Bye. Okay, so if I look at these two, and if I want to find the intersection, if you remember, intersect is where they overlap. So if I look at these two shaded portions, intersection would be in this area here. That's where they overlap. So if I want to find the domain, when I start performing operations, I've got to find where they overlap. So the domain of f intersects the domain of g, where? Everything from 3 to infinity. So the domain of that would be x greater than or equal to 3. So any operation I perform, this is going to be the preferred domain. Well, let's actually perform the operation. They want f of x plus g of x. Right here, f plus g at x. That means just to add the two functions together. Square root of x minus 3 plus the square root of x plus 1. Here I can't do anything. I can't add. I can't do anything algebraically to clean it up. So that's the final result. But along with that final result, I need to state its domain. And the domain is x greater than or equal to 3, which we found earlier by investigating each domain individually.